Let's just do quick check. Back to back live. Yes. I was like, इसके पहले कि next Leetcode weekly cancel हो. फटाफट अपन कर. Today's lunch will be suffered. Oh, for those who know, I have a class at 2 o'clock also. Okay. Hello everyone. 2 बजे से 22 से क्लास भी लोगे? हाँ भाई लूंगा टेंशन मत लो. तुम लोग पढ़ाई करने नहीं बैठ सकते 1-2 घंटे, मैं 4-4 घंटे पढ़ा लेता हूँ, मुझे कुछ नहीं. ठीक है. Okay. Google L3 only DSA is sufficient. Yes, Google L3 is all about DSA, I feel. Okay. Great. So, welcome everyone to Leetcode weekly discussion, bi-weekly and weekly discussion. I think we are doing this after a long time because of bunch of pauses. Like last week, my health was not good. Had to get admitted a little bit, but now I'm back. So we'll be having these sessions more often now, and I hope the online judge की answer दे रहा है. Okay. Let's see all the questions. We'll see. Okay. लीड कोड का सही हो गलत हो, हमारा सही हो गलत हो, आई थिंक एवरीबडी हु कम्स टू दिस स्ट्रीम हैज दिस कॉमन एजेंडा कि कुछ तो नया सीखना है, सम गुड आइडियाज, सम गुड इम्प्लीमेंटेशन टेक्निक. आई एम वेरी श्योर दैट नो मैटर विच स्ट्रीम यू अटेंड ऑफ माइन, प्रॉब्ली यू विल लर्न समथिंग न्यू, एंड दैट्स द एजेंडा फॉर इवन टुडे. कि विवेक, दैट्स व्हाट विल डू. Go to gym will be good, but when it's not good you cannot go, right? I was going week back before, but then last week तो health पूरा recovery के लिए मुझे देना ही पड़ा. ठीक है, चलो. Okay, we'll see the problems. Uber का इंटरव्यू है, ग्राफ शॉर्टेस्ट पाथ अच्छे से प्रैक्टिस कर लो. दैट्स माय टिप फॉर Uber. ग्राफ अच्छे से प्रैक्टिस करो. Okay, so how many questions were you guys able to solve in the 2 contests? Before we start, usual question, I'll share my screen. कितने questions बने? How many were you able to solve in the last 2 contests? I can see 2-2-2. Okay, 4-0. Nikhil, nice. 4-4. Perfect. Nice. 3-2. Biweekly 2. 1,3. Okay. 1,3. Okay, so you were trying to solve the 4th problem so that you can get the AC on this one, maybe. I think that is only what makes sense to me also. Like when there is a problem 1 and 2, I generally attempt the 2 first and then see 1, because if the same code can be copy pasted, then it saves time, right? Okay, so -2. So can I safely assume everybody was able to solve the 2 problems, and we can look at the last 2 problems of both the contest? Does that work? Because we have a lot of questions, and I have a hard deadline of 1.5 hours from here, 4th. So we will do 2 questions from both the contest, the last 2 questions of both the contests. Does that work fine for everyone? Okay. Okay, so that is what we'll look at, and we'll try to see how you should have thought, what are the topics involved, how to study that if required, right? Let's start with bi-weekly, and then we'll do the weekly wala thing. And I think weekly has a 6-7 pointer, and bi-weekly has 5-6 pointer. Okay, no issues. Should be doable. I feel as long as there is not an 8 pointer, we can discuss all questions. 8 pointers generally what I've seen is it's generally contains some idea which is too hard for even the live streams, because there is a limit to which I can explain, given that I don't know what you have learned till now, right? Most people would not be able to understand. Okay, let's look at the problems and let's try to see how we can approach it, right? So this problem, k edge path, there is a dag given to you, and there are weights on the edges, and there is k and t. You have to determine a path that contains exactly k edges, and the sum of edges weight in the path is strictly less than t. Okay, so I basically have a problem where you have to find the maximum possible sum of edge weights for a path which has two restrictions. The path contains uh, exactly k edges, and the sum of weights has to be less than t but as max as possible, right? So this is the two restriction that we are dealing with. Okay, great. So I don't know how you see problems when you read like this, but हाँ, ये कौन सा कमेंट आ रहा है? डैग विथ n नोड्स. तो डैग जब भी दिख रहा है, I generally think about it from the perspective of DP at the start. कि अच्छा DAG पे DP कर सकते हैं. Do you all agree that you can do DP on DAG? And there is bunch of restrictions. So restrictions आ गया, DAG आ गया, then the first thing that I think about is DP, right? Okay. Let's see the constraints one, because I think constraints will help us to decide. Yeah, okay, 300, 3. Okay, so there are 300 nodes. Weight of I is 10, and K is up to 300. What is K? Exactly K edges. So how many edges have you taken? You need to know that. And what are the different weights? What is the T? T is the maximum. Okay. So this is essentially, I feel, DP only, because you want to put all these things in the state that at a particular node, you want to manage these two restrictions. So I don't know if you have read my workshop or not, but most of the questions where you have certain restrictions, they go to state. If you have studied my DP workshop on YouTube, you should be able to understand this, that whenever you are dealing with a question where there are certain restrictions, like I'll just quickly pull this question itself into the uh, drawing pad. Okay, so whenever you have question, there are certain restrictions. What is valid, right? What is valid? The question says which paths are valid. So to maintain that a path is valid or not, you need to know that the path contains exactly k edges. This is something that are restrictions, and they have to be managed by the state. Okay, this has to be managed by states. That what is the current sum of edge? You have to maintain that and make sure that it is not exceeding the value t. Okay, and a path contains exactly k edges, right? So the path contains exactly k edges is also what you have to track. That how many edges does a path have? So suppose there is a path of k edge. So for that, to find the optimal value over here, okay, you need to know what all different, like, sum of weights less than t are possible of length k minus 1, right? So my thought process would be that if I am at a particular node X, right, and I want to figure out the best length with K path length, and I need to keep track of the sum of weight, definitely the last edge will be some W, and till this node you will have to have k minus 1 nodes, k minus 1 edges before it, and the sum, and you should try to take whether sum minus w is possible to be made in this or not. So I can simply say at a node x, dp of x comma k comma sum says, can I make a sum length path ending at node x with length k? Okay. Can I make a sum length path at x with length k? Okay. Can I make a, this is DP form 2. Path problems generally lead to form 2 in questions, right? I don't know if you have solved grid problems, if you have solved graph DP problems. DP form 2 is what is used to solve this, right? DP of x, k, sum. These two came from restrictions. Since it's a DAG, it's a form 2 problem that you are ending at this particular thing. Okay. So this is the node. This is number of edges. And this is sum of weight. So and this will return, can I make this? And how do I check if I can make it or not? For this particular node, you know that there are bunch of edges coming inside. Okay. You know the number of edges going inside. Yeah, I'm coming to optimization. I'll teach that. Don't worry. Whether this is possible or not. So if for all precursors A, B, C that are there in the graph, you can build the reverse graph if you want and process it. I can simply say dp of x comma k comma sum is possible if either you have dp of a comma k minus 1 comma, say this is w1, w2, w3. So sum minus w1. Okay. dp of a comma k minus 1 comma sum minus w2, b comma sum minus w2, and so on. If this is possible, then this is possible. If this is possible, then this is possible. So there is a bunch of or between all of these things. Does this make sense to everyone? That if this is possible, or this is possible, or some other thing is possible, then only this is possible, and there is a or between them. Does this make sense to everyone? That this is a possibility, this is a possible way of solving this problem. Okay. DP on DAG, generally you solve questions related to that on finding the longest path and stuff like that. But I mean, there's no such topic list for DP on DAG, I feel. General DP should be strong to be able to solve this. You should be able to solve this problem. If you know that how to manage these restrictions into states. Okay. So if this is the thing that you have to calculate, then we are done with the DP problem. Yeah, there would be problems like this on CSCS and stuff. Yeah, I'll agree. But I don't remember any specific one. Okay. Now, generally, when I see this problem, I first of all think about how much time complexity. Next step would be, this is the transition. Then we'll do the time complexity check. So the formula is number of steps into 1 plus number of transitions, right? Average number of transitions. And if the number of states is the number of vertices into, in the graph, number of vertices into the k possible value, which is around 300, I think, and into the sum, which is t, which is 600, I feel, right? Into 1 plus average number of transitions. What is the average number of incoming edges on every node? Number of edge divided by number of vertex. This is the average number of things. This is average number of transitions, right? So number of edge divided by v. So if you calculate this, if you take this v inside, it will be e plus v, very similar to DFS. So v plus e into k into t will be the time complexity. This is 300, this is 300, and I think the rest is also 300, sort of 300 only, right? Let me check once. I don't remember the numbers. 300, 300. So yeah, that is there. 600. Okay. Yeah. So this should be good enough. And the weights are fairly small. Like there are only 10. The weight values are 10 only. That is good. But then the problem with this code might be that when you create a 300 cross 300 cross 300 array, the yeah, the sum is 600 and this is also 600. Okay. Like n cube. What I mean to say is 300 cube. Okay. 300 cube is something that generally passes. Okay. 300 cube is generally something that passes. But the problem with this is uh, the memory of this might be very high for every test case to be calculated, right? Memory of this is going to be fairly high. So then we need to think of how to make this memory faster. Number one. So need memory fast. Number two, whenever I see that I have to optimize something and I need to deal with ors or ands, I think of Bitset. Okay. When my DP stores, is it possible or not? I think, can I do this problem with Bitset? And if you see it with Bitset, actually the thing becomes very, very easy. Okay. Why? Suppose you are at this node A, and if you see x length paths that are there, say the possibilities are that you can make a total weight of 2, a total weight of 5. Okay. Okay. So I can, if there is an edge from here to this particular node B, then for B with x plus 1 number of edges, you can do, and if this is weight 3, then you can possibly do 3, 5 comma 8 in this node. Does this make sense? That if this is possible here, then this is possible here, because you can come with 3 plus 3 on both of them on to get this particular weights over here. Does that make sense? Yes or no? Correct. अरे हाँ ना बोलो भाई कुछ. If you can make these sums at this node with x length, at x specific length, can I make these values over here with x plus 1 length? Yes or no? Correct, right? If you can make these here, you can make these here. So I can encode this in binary. Like I'll maintain 0, 0, 1, 0, 0, 1. So this is, I'm writing the binary in reversed way. So it's like this is 0, 1, 2, 3, 4, 5. I can just simply say that if this is of length 3, I'll shift. Okay, let's write it in the normal way only so that you can figure out what I've written. So this is the place 2, this is place 5. If this is weight 3, then I can shift it by 3, and this is the new possibilities that will be available over here. Right? If this is possible here, if I shift by 3, then this will be the possibility over here. Clear, everyone? This is bit set optimization on top of DP. Okay, when you have or and stuff in the problem. So this is one thing that you can possibly use in this question to make it a little faster, and the memory will also be fast. Like both the time complexity and memory complexity will get divided by 32, which is enough for this problem. Okay. Should we try to code this? Yes or no? Okay. So for every node, you will maintain the feasibility at that node, and then accordingly you can do this. Okay. Great. Let's try to write the code for this, because I think some of you like, because it's not too hard to write and there is good learning in this problem. Okay. So I have the graph over here. I think, what is the edges? Okay, edges are given. Will I have to convert it to edge list? Yeah, I'll have to convert it. So vector. I'll write iterative code just to make sure that I don't have to write too much code, because it's uh, right. So there are n nodes. It's zero index, so I'll keep it zero indexed, right? And so this bitset, we are saving the possible lengths. So I'll maintain bitset of length 600, because up till 600 it's possible, right? Strictly less than t. So if t is 600, we have to do less than 600 only. So bitset 600 dp of the n nodes up till k plus exactly k number of edges. So this is the dp that we maintain. Okay, and this is the graph. So first I'll go through the whole edges. Auto v in edges, g of g of v of 0 dot pushback, g of v of 1 comma v of 2, and I'll make it pair because it's a weighted graph, right? This is something that we'll do. And since it's directional, so there is nothing much to do. No, I don't want to use GPT. I'll write short code and I'll teach. Please don't leverage GPT always. It will mess up your implementation skills. Okay, don't over rely on GPT, guys. Okay, now next is, once you have this graph, I'll just simply, so see, whenever you are at k length, you will update the k plus 1 steps. So I can simply go ahead and do for len equal to 0, len is less than k, len plus plus, right? So we will set up the base case and then do iteratively. So for integer I equal to 0, I is less than n, I plus plus, dp of I comma 0 is nothing but, it's 0 length is possible, rest everything is false. Nothing is possible at 0 length except 0 weight sum. Now what we do is we go from length 0 till k, and for every node, for integer node equal to 0, node is less than n, node plus plus, we'll go through its neighbors. Auto v in g of node, we will say dp of v dot first, the length will be current length plus 1. So this node's this length state, this node's this length state will all get shifted by v dot second, and that particular value will influence this particular states. Whatever things are possible at this node at this length, if you shift it by the edge that you are traversing, all those values will be possible at this neighbor with length plus 1. So we are propagating this value forward. This is called forward dp. In implementation, you need to write a lot of things, right? You don't really need to do topological ordering, because length itself gives you the topological ordering. Like length will influence length plus 1, so you can simply loop on length order and it will not create any issues of dependency not being calculated. Yeah, that's pretty much it, and you're done with the whole dp code. Dp khatam, question. Okay, and then then you just need to figure out the answer. What is the answer? For such a path, if there is no path such exists, then this. Okay, so we'll just loop through now every node. For integer node equal to 0, node is less than n, node plus plus, and we know the limit for integer t, like x, integer best equal to 0, best is equal to -1, because if nothing is possible, then we should print -1. So we go through all possible weights less than t. We just figure out if dp of node with exactly k length and with some t is possible, then best equal to max of best, comma, the length. Yeah, that should be pretty much it, I feel. Right, that should be it. Clear, everyone? How did we optimize this thing? This is a very good optimization actually, right? Because number one, if you see, there are so many things I thought very fast, but I want to articulate it so that you can see this next time. Number one, you have to build the graph, but I did not do any topological ordering because length depends on length plus 1, so I can just simply loop over here and I don't need to resolve the topological ordering of the nodes. Okay, next, bitset of this 600 is allowing me to propagate the values fast. So anything that is possible here, it's like a set plus this, all of those things are possible here. Yeah, you can make it faster, but I don't think it's required right now. Okay, like you can make a space optimization like making this a 2, right? And you can just do a and one trick here to make it even more faster. And this will also give you correct answer, and suddenly there is more space saved. Okay, this is something I've taught in the optimization part of the DP course, that you can make this, like when first layer depends on the next layer, you can just put a and one and suddenly it optimizes everything, and you can do it in n comma 2 instead of n comma 10, n comma k, right? Crazy trick. Learn it from the DP workshop if you want to. Okay, these are the kind of things we will look at even in the ICPSC camp. Okay, the camp that is coming will look at all these tricks also. Okay, what was that black magic? This is magic trick. Okay, like when you are going through length, you can make it and one on different things and suddenly it becomes 2. The complexity, time complexity is same, but space complexity reduced by a k, because this much array is easy to make. Okay, these kind of tricks we'll learn in the ICBC camp. I have also taught it in the AZ Premium DP course, but I think we'll also cover a lot of these things in camp. I'll talk about a lot of DP optimization in the camp. Okay, all these black magic we'll learn, because I think if you have seen the camp page, there's a lot of magic written over there. What does magic means? Exactly this. Or those who are my students in AZ Premium already knows what does magic mean. है ना? कुछ तो right. But yeah, currently able to solve 2 questions on average. I have purchased your camp yesterday. Will I be able to solve? So camp is not exactly 100% curriculum, but yeah, it will definitely help you to reach till fourth problem. But it's not exhaustive as such. Okay. But yeah, you will see a lot of growth because of ICBC camp, even in Leetcode contests. These kind of tricks we'll discuss in that camp. भाई आपको क्या लगता है लड़ाई कब होगी? आई थिंक आफ्टर दिस मंथ आई थिंक इट्स predicted टू गो ऑन, सो नेक्स्ट मंथ ऑनवर्ड्स। ओके, लड़ाई कब रुकेगी? मतलब वो तो एक रैंडम सोर्स ऑफ एंटरटेनमेंट है ही। एंटरटेनमेंट नहीं, आई विल से इट्स एक्चुअली अ मेजर इशू जो रिजॉल्व होना है। बट आई थिंक मोस्ट पीपल के लाइफ में, जिनके लाइफ में बोरिंग हो गया था लाइफ, पीपल आर लाइक ओ कुछ तो चल रहा है, राइट? You will teach greedy there as well? Yes, I'll teach greedy because I had not mentioned it, but I'll teach because I think that's a place where a lot of people struggle. A lot of students told me this. है ना? न्यूज चैनल्स तो कुछ भी दिखा रहे हो भाई, न्यूज चैनल्स का तो भरोसा ही नहीं करना है भैया। डीपी ऑन डैग, भाई डीपी ऑन डैग का और कोई प्रॉब्लम नहीं है। अगर ये प्रॉब्लम समझ के दैट्स एनफ, देयर इज नथिंग न्यू। सो सी, यही मैं बोल रहा हूँ कि विवेक मुझे डीपी ऑन डैग के सारे क्वेश्चन दे दो, ऐसे मत सोचो। ये जनरल डीपी का ही एक्सटेंशन है। मैंने जनरल डीपी से ही इसको सॉल्व किया है। इट्स नॉट अ न्यू थिंग, जस्ट दैट क्योंकि ये डैग है तो यहाँ पर नोड रहेगा और कुछ नहीं। बाकी ये सारा पार्ट तो जैसे डीपी सॉल्व करते वैसे ही आया है। रेस्ट्रिक्शंस को मैनेज एग्जैक्टली के चाहिए तो के को स्टेट में डाल दो, लेस देन टी चाहिए तो सम को स्टेट में डाल दो। दैट्स व्हाट वी आर डूइंग। क्लियर एवरीवन? When will you teach B9? Yeah, so it will be taught in the camp and it will be common class for all. So I'll invite all of you, Aditya, don't worry. हाँ, कॉइन कलेक्ट लाइक डीपी में ये सेम ऑप्टिमाइजेशन काफी जगह पे यूज होता है, ठीक है? कॉइन कलेक्शन भी सिमिलर ऑप्टिमाइजेशन से सॉल्व हो सकता है। ओके, सो देयर आर लॉट ऑफ ब्यूटीफुल आइडियाज इवन इन कॉइन कलेक्शन। तुम लोग को मतलब डीपी में ऐसे बहुत ब्यूटीफुल आइडियाज है। मतलब व्हेन आई विल टीच इन द कैंप नाइट, मजा आ जाएगा। मतलब लाइक आई कैन गारंटी यू दैट। मतलब मैं बहुत सारे टेक्निक्स नहीं पढ़ा पाता हूँ बिकॉज समटाइम्स आई हैव टू लिमिट माई सेल्फ एट टाइम्स फॉर इंटर्नशिप प्लेसमेंट्स एंड स्टफ। बट इफ आई वांट टू टीच तो फिर तो मैं कुछ भी पढ़ा सकता हूँ, मुझे ऐसा लगता है। ठीक है सर, आई एम फ्रॉम B9, गॉट प्लेस टुडे, थैंक यू, सुपर हैप्पी प्रियांशु। विल चैट ऑन द स्लैक आफ्टर दिस, ठीक है? Clear everyone? Is this problem clear? Let's move to the next problem. We are on a time clock today. Whenever you have a path, it's a form 2. Length ending at node x. Ending at node x. Can we make this ending at node x? It's a form 2. Okay? Path wale problems form 2 hote hain. Path, breaking array and stuff like that. Clear. Chalo. Next problem. Shall we move to next problem? Quick +1. Okay. When you invert a node, every value in the subtree in that node is multiplied with -1. Okay, inverting a subtree. And you need to be sufficiently far. The path length, you invert two nodes such that one of them is ancestor, then the distance must be as least k. So I need to maintain where was the last update happened to decide whether I can invert here or not. And if I invert here, I need to maintain how many inversions have happened in the ancestors, so that whether it's -1 or +1 that is getting multiplied in this current node is what we have to decide. Maximum possible sum of the tree nodes value after applying operation. So this is, as soon as you read this problem, you should immediately think tree DP, right? As soon as you read this problem, you should immediately think tree DP. Why, Vivek? Why did you get into tree DP immediately? How did you think about it? Okay, because first of all, there are too many choices. Invert a node and every subtree. If you have practiced tree DP, this is a very classic setup where when you have to do something on the subtree, you can possibly do it with tree DP. Okay. Second is you need to maintain where something has happened last. So when you are at a particular node, you need to track कि इसके ऊपर last update कहाँ हुआ था. And the other thing that you have to update is from root till here, how many updates have happened, because that will multiply -1 to the power number of flips. That will decide the actual value here. And the second thing is you need to maintain how many, where was the last thing that happened. Correct? Yeah. So these are the two things that is what matters to decide the value here, as well as whether can you flip. Since you are flipping a lot of things, it is probably a DFS problem. But since to decide, you need to know what is the current value based on previous like flips, and can I even flip this one based on previous choices or not, and it will become a tree DP problem. Okay? And you need to maintain, obviously, is the value positive or negative in the state. Flip will be there in the state. The next thing is, can I flip, depends on the last, how far last update, how far was the last update. These two things you will have to maintain in the state. So what will I think about in this problem? I'll just think, yeah, this is ancestral DP. In tree DP there are three from. Number one is knapsack DP, in out DP. Two, there is knapsack form. And the third is ancestral DP. Okay, what is in out DP? In a graph, for every node you calculate the best answer in its subtree and best answer outside the subtree, and then you merge them. This is called in out DP. What is knapsack DP? When you have a particular k to be distributed in multiple subchilds, then you do some sort of knapsacks on the child nodes of that particular node. And then there is something called as ancestral DP. No, rerouting is different. Rerouting is, if you know the answer of this, can you calculate the answer of this particular node? This is called rerouting. Okay. In out DP is, from this node you calculate two different DP values. One is outside answer, one is inside answer. Okay. Knapsack DP is, if suppose you are at this particular node and you have to choose k nodes in the tree. So you will distribute this k into k1, k2, k3, k4, and this node taken or not, and this sum has to be equal to k. It's sort of a knapsack problem. And the third is ancestral, where you are at a node, so you maintain things like whether have you taken the parent, how far have you taken the last node, what is the GCD of path from root to the current node, things like this. These are the three different form ideas that exist in tree DP. इससे बाहर नहीं आएगा, इससे बाहर 2100 के नीचे तो नहीं आ सकता प्रॉब्लम में कभी. ठीक है? So this is what you need to practice, and this problem is mostly about ancestral DP, because you have to track two things: DP of current node, what is the, like, how many flips has happened in the ancestors, flips. You can maintain the count, but actually only the parity matters, because if you do the flip twice, then it is the same thing. So this will be a 0, 1 value. Okay. And the next thing that you will maintain in the node is how far the last update. Okay. So this is the three things that you will maintain, and from this you can calculate this DP. Okay. Very sorry to ask, but do we have recorded classes of season 2? The season 2 will be recorded and it will be added in AZ Premium later on. Okay. Anik, it will be on my mood. ठीक है, मेरे को जो मूड करेगा मैं वो पढ़ाऊंगा कुछ टॉपिक्स. ठीक है, बट मोस्टली जो लिखा हुआ है वो तो पढ़ेंगे हम लोग, टेंशन मत लो. बट या कंस्ट्रक्टिव ग्रीडी विल कवर. ठीक है यार, तुम लोग ऐसे क्यों सोचते हो कि विवेक ये टॉपिक वो टॉपिक? भाई अच्छे टेक्निक सीखने के लिए बैठो यार, कि विवेक कुछ अच्छा टेक्निक बताओ मेरे को, ये अच्छा टेक्निक सीखना है मेरे को. ओके, ऑल दोस थिंग्स विल डू. ओके, so this is what you maintain for this node, and let's see the question once more just to figure out. Must be at least k. So I can start with DP of node number 0 because that's the root. Flips, I have not done any flips. And what is the last update? Last update is at k. What is the best value of sum of the subtree? Best sum of subtree. Whatever was asked in the question, best sum of the subtree. If you are in this configuration, what is the best sum of the subtree that you can calculate? So for this node, the last one as at k distance, which means you are free to flip here also. So at this node, you can choose whether you want to flip or not, and you have not flipped anything yet. And there are childs. So there are two things. One thing is you can do a flip. In this case, you will go into minus val of the zero of the node. Suppose you are at this node, okay, and node nn. So dp of nn, let's say you have not flipped and the last node was at distance k. So from here the possible transitions are, if you flip, then you will get minus val of nn, because this is 0. If it is flipped already, then it will be plus nn, plus dp of sum of dp of child. They will all be flipped, and you will be at one distance from the last flip, so you cannot do this. Okay, this is what you will go to. And if you don't flip, then you will possibly go to the same value plus dp of, you will go to the child. You have not flipped, and the distance will be k plus 1, but I will max it, like min it with k always, because distance more than k does not matter to us. So I'll keep it like this. Okay, this is what I'll maintain over here. These are two options. So nn, I think there are 10 to the power 5 nodes. This is 2, and k was, I think, up till 10, if I remember correctly. It's 10, right? Oh, yeah, 10. 50. ठीक है, 50 भी चलेगा. So 10 to the power 7 complexity. There are only 2 transitions. Okay. Rishabh is asking a good question, that how to come up with such great intuition like Bitset stuff and stuff. How can I learn and think in that way? I have seen these tricks in question. I would highly encourage most of you to watch this particular video by Arpa, right? I don't know if you guys, I'll show this video on screen, right? This is a video by Arpa, and like you can watch this video once. People feel ki these are all intelligence. I am coming up with these things as intuition, whereas it's not true. He is also like a super known person. Like I used to read from his blogs when I was learning. Okay, he'll also be teaching in ICPSC camp, by the way. So uh, he had talked about intelligence versus like practice. If I don't know this trick, you have to come up with it, which is extremely hard. But it's not possible for most people. I cannot also come up, like if I don't know, I can never come up with the trick I showed you earlier. This trick that I showed you earlier, if I don't know this, if I never seen this before, I can never come up with it on my own. It's very, very hard. But once I see ki, when I maintain possibility yes or no, and I need ors, I can do this trick. Next time I will think about it, right? Whenever I need to optimize. That is how people improve. In the last question, when regarding subtree, when there are queries on subtrees, for every subtree, if you are calculating, if there are updates and queries, then you go to Euler tour. Yash, you did not hear me properly. When you are a static tree, then you use TDP. When there is dynamic changes, like there is updates and queries happening, then you use Euler tour. Okay, this is the DP for this problem. Watch this video that I showed. This video, I'll probably link it. Right. Shout out to Arpa on explaining that very well. हाँ मतलब टूल्स उठाना है यार. पीपल फुल सेइंग कि बहुत ज्यादा तुम्हें आईक्यू चाहिए. नहीं चाहिए भाई, मैं बता रहा हूँ मैं बहुत हाई आईक्यू इंसान नहीं हूँ. लाइक I have just solved too many problems at this point to have seen these tricks before. 80% of it is that. 20%, because I've seen so many tricks, is probably I can think of new tricks as well at times whenever it's required. But that's just 20% of problems. Even less probably. Leetcode के कोई भी क्वेश्चन में मैं कोई नया ट्रिक नहीं बनाता हूँ. Most of these ideas I've seen before, and that's why I'm able to solve it and you are not probably. यही difference है सब में. ठीक है. It's not about IQ or building creativity. It's very very hard to do it. You can do it. ऐसा नहीं कि तुम नहीं कर सकते. You can build it with extreme practice, years of practice actually. But not all of us has time. कौन याद रख पाएगा मेमोरी? आई डोंट मेमोराइज इट. आई ऑलवेज हैव अ फ्रेमवर्क. तुमने देखा नहीं कि मैंने कैसे सोचा ट्री डीपी होगा, क्योंकि स्टैटिक ट्री है ना, हमें सब ट्री चाहिए, उसमें 3 आइडियाज पॉसिबल है. मैंने देखा मुझे एंसेस्टर्स से लिंक करना है, तो आई नीड एंसेस्ट्रल डीपी. इन एंसेस्ट्रल डीपी आई हैव सॉल्व प्रॉब्लम्स वेयर आई हैव मेंटेन this particular type of state I have seen in an array problem, so I use it. Okay, that is how I do it. I don't have high IQ says. Nay, if you think that is true, I have worked extremely hard. You matlab, you would not be able to estimate the amount of hard work I have put in to get the result, even if I don't have sheer high IQ. इतना मेरा, फॉर यू ऑल इट माइट सीम लाइक IQ, क्योंकि तुम लोग को दिख रहा है कि मैं तो फटफट सॉल्व कर रहा हूँ, सो इट माइट फील लाइक अ वेरी गुड IQ. बट मेरे एंड पे इट्स नॉट IQ. It's pure I'll say experience. Is experience equal to IQ? I don't think so. तुम अगर किसी चैंपियन किसी भी डोमेन का देखोगे, क्या IQ थोड़ी होता है ना? No, don't think taking solution is cheating. Like, I think you should learn from solution after 1 hour. 1 hour is a higher threshold. इतना देर सोच लिया तो उसमें अगर नहीं चमक रहा है, so then you can do it. Exactly. These things are now muscle memory for me. That's why you might think कि ये बहुत मेरे को easy लग रहा है. Even for JEE probably it was like a lot of practice. सब चीज ही muscle memory होता है. मतलब at the top level it's mostly muscle memory that differentiates. It's not sheer intelligence. मतलब एकदम एक्सट्रीम टॉप में हो सकता है, मतलब गेनेडी के लेवल पे होगा कि एक्सट्रीम इंटेलिजेंस होता है, बट Arpa had told this, that anybody who is at the top is perfect at implementation and perfect at knowledge. Then only IQ comes. Okay. So this is what we are. We have to learn. Okay. Clear everyone? Next problem पे move करें फटाफट. This should be the tree DP. Now, if you have learned tree DP, this should be direct for you. But if you haven't, then learn tree DP. क्लियर एवरीवन? नेक्स्ट पे मूव करें फटाफट. क्विक +1 दे दो एक बार चैट पे. नेक्स्ट विल मूव टू लीटकोड वीकली आई थिंक. आईफोन फ्लेक्स. भाई आईफोन आज के टाइम में कोई फ्लेक्स रह गया है? ये कोई बोलने वाली बात हुई? वो भी मैंने जब आई जॉइंड गूगल, देन आई हैड जॉइंड, देन आई हैड टेकन आईफोन 13. वही है मेरे पास. आई डोंट, you might feel कि I keep upgrading to new stuff and all, but it's not the case. I'm not that spendy. ये विश्वध्वज को भाई अलग ही कुछ अलग ही दुनिया में चल रहा है विश्वध्वज. अलग मेमोरी का सहारा. ठीक है, तो समझ गए. तुम्हें अगर मेमोरी तुम्हारे पास नहीं है तो फिर टीम में किसी लड़की को लो, अगर तुम्हें मेमोरी चाहिए तो. डब्बा थ्योरी. किसी ने मेरा C++ का डब्बा थ्योरी देख लिया. ओके, एवरीथिंग इज अ बॉक्स, है ना? विल सी. नेक्स्ट पे मूव करें. चलो, वीकली में कितने क्वेश्चन बने थे? गिव मी क्विकली ऑन द चैट. Question 3 is wrong. Is it so? I don't know. Let's see. इज क्वेश्चन 3 रॉन्ग पक्का? रॉन्ग है तो फिर टाइम वेस्ट नहीं करते. देख लेते हैं, मतलब टाइम वेस्ट नहीं करूंगा यार मैं. इतना टाइम नहीं है टाइम वेस्ट करने लायक. तो क्यों बोल रहे हो गलत है फिर? क्यों गलत है निखिल? व्हाई इज दिस रॉन्ग? ओके. इज देयर अ ब्लॉक फॉर दिस वेयर यू आर सेइंग कि दिस इज रॉन्ग? मतलब अगर गलत है तो टाइम स्पेंड नहीं करेंगे. 20 का तुम टेस्ट केस दोगे तो कहाँ से मैं टेक करूंगा भाई, ये क्या बना के ड्रॉ करूँ? चलो ठीक है, लास्ट में आते हैं इस पे. अगर लग रहा है कि कुछ गलत है तो लास्ट वाला प्रॉब्लम सॉल्व है. ये तो करेक्ट है ना? 400 प्रॉब्लम पीपल आर लाइव ऑन दिस. ओके, जस्ट कॉपी पेस्ट टेस्ट केस. ओके, विल टेस्ट इट लेटर देन. ठीक है. विल विल लुक एट द प्रॉब्लम एनीवेज एंड ट्राई टू थिंक रीजन. अगर नहीं भी हुआ तो देख लेंगे आइडिया. ठीक है. लेट्स गो टू द लास्ट प्रॉब्लम बिकॉज अब तुमने बोल दिया है कि कुछ गलत है तो पहले सही प्रॉब्लम तो कर ले. ठीक है. यू आर गिवन अ m क्रॉस n मैट्रिक्स. ये कौन देता है? चलो ठीक है. Your task is to determine if it's possible to make either a one horizontal or vertical cut such that each of the two sections forms is non-empty. Okay. The sum of the elements of both sections are equal and can be made equal or can be made equal by discounting at most one single element in total. Okay. If a cell is discontinued, the set of the sections must remain. If a cell is discounted means zero ना, तो हटा देंगे उसको. Okay. Okay. Nice. Okay. Yeah, this is I think straight up implementation only, no? Because if I have to think about it, if I make a partition to check if they are same, I just need a prefix sum. ठीक है. तो prefix sum से निकल जाएगा. And like I can maintain the two sides in a set, in a multi set to check कि जो डिफरेंस है दोनों में, क्या वो एलिमेंट जिस साइड ज्यादा है वो वहां पर अवेलेबल है कि नहीं, क्योंकि दैट इज द एलिमेंट दैट आई हैव टू डिस्काउंट. Okay. With an only edge case being that when the length is 1 on one of the sides, you cannot delete a middle element, नहीं तो वो disconnect हो जाएगा. Because this is making it disconnected. Okay, so that is the case that we'll have to implement. ठीक है. This is an implementation problem. There's nothing much to teach here, but it's a good problem because you need to be able to think about it clearly. देखो मैं कैसे सोच रहा हूँ, like when there is a n cross m possibility, ठीक है, there is a n cross m grid. So what are my possibilities of cut? Here, 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 here. ठीक है. तो O of n plus m possibilities है. For every one of them, I cannot traverse the whole matrix, or else it will become nm into n plus m. Will that kind of complexity be allowed? I don't think so. है ना? N into m is pretty big, so I cannot do that. So I need to make it fast. So when I'm thinking about a particular line, I need to be able to quickly find whether this is equal to this or not. That is a very direct problem of prefix sum. All of you know what is prefix sum. That if you find the sum of this cell, it will contain the sum of this much, and total minus this will be the sum of this particular thing, right? So this is, with prefix sum you can find whether there are two like partitions of same size or not. If they are not, then let's suppose this is S1. If you make this line, if this is S1 and this is S2, then if S1 is bigger than S2, you have to delete exactly S1 minus S2 from this side. If you have to delete, if this is S1, S2, so how much is this bigger? S1 minus S2. So exactly one element that has to be deleted has to be of this value only so that they become equal. So I will need to check in this set, is that element available or not. So as I move this line forward, I can remove these elements from this side and put it to this side. That is how I will manage the maintenance. So what I will do is, if I have a grid like this, suppose like this, so 1, 2, 3, 4, 5, 6. So when I have this line, I will build two sets. One will contain 1 comma 2, and another will contain 3, 4, 5, 6. Now for this line, I will check the sum of the two sides and see if the difference is available or not. So here I don't think difference would be possible. So now we need to make this line go over here. So to make it go over here, it's like moving this 3, 4 from here to here. Okay, so now this is the set. We will simply check the sum. This is 10, this is 11, so this is larger by 1. So I need to remove 1 from this side, but 1 is not available in this set, so I cannot do it, right? So that is also not feasible. Then we will try some other line, like this line. So in this part, we'll have the sum as again, I think this side is more than this side by 3, but 3 is not available on this side, so we cannot do it. Okay, so the only trick is, only the tricky part is, if it's 2 cross 2 or 1 cross something, you have to be very, very careful about the disconnected part. Okay, so 2 cross 2, everything deletion is allowed. You can try both the lines. For 1 cross n or n cross 1, you have to make sure that when you are at a particular line, you can delete this and this only, and this only. Rest cannot, you cannot delete. That you have to check. And for rest of the types, like this or a big array, when you are making a line which contains just one element on both the side and some n on this side, you cannot delete these middle elements. Like if you make this line, if this is 1 cross n, you cannot delete these middle elements, because if you delete this element, then this part and this part will get disconnected. So these cases you will have to handle separately in the implementation. I don't think anything else should be a problem, right? So I would, if I would have been going about implementing this for a line, I'll just figure out the shape, and based on that I will check what I can delete. Either I can delete only two elements, just this or this, or this or this, or if it's not 1 cross n, so whenever I make a cut, I will see the portion sizes. If any of them is some 1 cross n, where n is greater than 3, then I can only delete the extremities. Or else if it's any other dimension, then I can delete any element. Just maintaining these two things will help me to implement the code. Clear, everyone? This is how you go about planning an implementation. Matlab, before even writing my code, I am thinking about all these things. Then only I code. I don't go and like start typing on whenever I read a problem. Okay. Heap and stack. So there are different like stack applications that you will have to learn. And heap mein there is like cut point ideas that exist. Like there's a technique of maintaining the median and all in heap that you need to know. I think these are standard forms only. So there are two in heap. There are two ideas. Heap nahi hai, any sorted set, you can maintain a fixed k comma rest cut point, and you can maintain half the size cut points. This is a trick that you use in using priority queue or um, multi-set anyways. And stack method, there are like standard ideas that you need to know about. Next greater, previous greater, and stuff like that. So these are things that you'll have to learn. But this is how you go about implementation in general. I plan these things in implementation stage, and then I go and type. Okay. When you say heap and stack, practice a lot of questions of STL. I think most underrated practice that people do is of STL. If you haven't practiced STL well, I think you should. It's one topic that people forget to brush, which actually matters the most. Okay, cool. Let's go back to this. You are given an undirected graph of n nodes, number 1 to n, and each node is connected to at most two other nodes. At most two other nodes. So it's either a tree or a cycle. Two cycles cannot be there because they have to be connected. Each component will either be a cycle or a tree, will be a perfect cycle or a tree. Okay. The graph consists this is this. You have to assign unique value of 1 to n to each node, and the value of each node, each edge will be product of the values assigned to its two. Oh, nice. Your score is the sum of values of all edges in the graph. So pairwise product we have to maximize, and yeah, let's see. So bunch of pairing is there. This will become three. So we cannot have this. Oh, it will always be a path or a tree or a cycle. It will always be a path or a cycle. Yeah, it should either be a path or a cycle. So yeah, seems like a greedy problem. Somebody was mentioning in chat it's a greedy. Uh, how do I put, so this node will have 2 degree, like it will be multiplied by two numbers, and these nodes will be multiplied by only one numbers. So obviously the smallest number goes here, right? Smallest number goes here because it will be multiplied with only one value. And if you put the smallest number, then it's a recursive problem again, that now you are dealing with 3 to 10. You should put 3 here, 4 here, and 5 here, then 6 here, 7 here. Should be 8, 9, 10, 11. No, but 11 will get multiplied with this. I think better we can do is 6 here, and then you should delete this. So it will become like a chain. So this will, then you put 7 here, 8 here. So this should then get deleted. So 7 here and it's deleted. 8 here and it's deleted. Then 9 here, this is deleted. 10 here and then 11 here. I think this is better now. Yeah. I think cycle wale mein it might be a little. How to prove greedy here? So one thing I can think of, like every element has degree 2 maximum. So the extremities will have the smallest values, that I can guarantee you, right? That these extremities will have the smallest possible values. Okay. So those things so we'll put at the very very end. And then so basically paths have lower preference. Okay. Then if there are two cycles, I think it makes sense to put bigger numbers in the cycles in a bigger cycle, right? Bigger numbers in the bigger cycle. I think two cycle is not possible. Why? Possible though hai. If there are multiple cycles, then I'm just thinking which one to put first. And I think bigger one makes sense because around the smaller things more like, so what is changing? Okay. Like think about it this way. I'll try to reason it in this way, that if there are four things, okay, let's suppose it makes sense to think about, like if 6 7 8 9 10 11 is here and 2 3 4 5 2 3 4 5 is here, right? So you will definitely put 6 in one of the nodes, the smallest number, and इस पे 2 डालोगे, right? Okay, if you are putting it this way. So now if you think about the rest of the chains, अगर मैं 6 and 2 को हटा दूं, so this is the greedily the best way to fill the graph anyways. ठीक है? तो 6 and 2 में से 6 को यहां रखना बेटर है या 2 को यहां रखना, या फिर 2 को यहां रखना बेटर है, because it makes sense to keep 2 here because it will give me local minima. So if you swap two values, it's better to keep the smaller value in a smaller cycle itself if you are doing this strategy. That इसको अगर fix कर दिया तो you can remove this node and the rest is a path वाला strategy, same thing. तो it's better to keep the smaller value in a smaller cycle because उसका influence कम होगा. एंड आई कैन ऑल्सो सी इट बाई द वैल्यू इट सेल्फ कि बाकी सब इधर सेम भी आए बड़े बड़े चेन के साइड से, बट ये लास्ट वैल्यू का जो इन्फ्लुएंस है वो कम हो जाएगा, राइट? इट्स लाइक इट्स लाइक पुटिंग दिस लाइन हियर एंड कटिंग दीज टू लाइन्स. ओके, आई गॉट अ वेरी गुड एनालॉजी. क्या हो क्या रहा है? इफ वी आर गोइंग टू पुट 2 to 5 over here, तो इट्स लाइक it's like moving this here, moving this here, and putting a line here, removing this line. ये चार चीजें चेंज होने वाला है ना? ये चार चीज चेंज होने वाला है. तो you can try and prove now that what is going to be the, like, this particular value based on like n number of nodes. Like if we go from this configuration to this configuration, you can see that these are the three lines getting added and these are the three lines getting deleted, right? And now we need to see that what is the change in the whole graph. So kya ho raha hai add? Like if I see a general graph also, like for 9,8 I'm, so let's try to make 1:1 like comparison. 9,7 के जगह पे मेरे को 7,5 मिला, 8,6 के जगह पे मेरे को 6,4 मिला, एंड 5 like 9,8 के बगल मतलब this is what I'm getting, and for this is what I'm getting for this, and here I will get one benefit which is 9 into 8, but I'm losing 5, 4. Okay. ठीक है, तो बस इसको बस कंपेयर करना है हमें कि इज दिस फ्लिप even better for us or not. So we'll have to prove it. Nine seven seven five 8664. So 9775 which is bigger हमें डिसाइड करना है. 8664 प्रोडक्ट प्लस प्लस हो रहा है 5498. So if I write 987654, either you draw एक साइड पे, जैसे इस साइड पे क्या हो रहा है, ये पेयरिंग है और एक साइड पे ये पेयरिंग है. Which is better between these two is what we are essentially trying to do. Compare. I think यही बड़ा आएगा. This is, I think, what we'll have to compare. कितना आ रहा है बताओ? Let's make it 1 2 3 4. 1 2 3 1 2 3 4 5 6. 1 2 3 4 5 6. 6 4s are 24. 5 3s are 15. 2 6 5s are 30. 4 2s are 8. 3 1s are 3. तो इधर का 1 का डिफरेंस है +1. हाँ, तो दिस इज 38 + 1. इधर तो बहुत ज़्यादा है. This seems to be better. इधर से if I remove 6, this is 9. Is it coming same? कितना आ रहा है? 24 plus 5 3s are 15 plus 2. This is 41. 30 plus 8 plus 3. 41. दोनों सेम आ रहे हैं. Okay, let's do it for 98765. 9 into 7 plus 8 into 6 plus 5 into 4. ये कितना आ रहा है? 131. 9 into 8. 7 into 5. 6 into 4. 131. ये दोनों सेम ही है. They're always same. Yeah. Oh, nice. I think we'll have to prove it then. तो फिर कैसे प्रूव करें? This is then another possible solution. Yeah, this will always be same then. I think it's only because the difference is 1. प्रूफ करना तो मुश्किल लग रहा है मुझे भी अब थोड़ा. इसने प्रूफ डाला है क्या इसका? अच्छा. प्रूफ का है. बट अच्छा, इसमें ऑनलाइन जज ही गलत है. ओके. ओके. क्या कर रहे हैं ये सब भाई, क्या कर रहे हैं लोग ये सब कोड में. बाप रे बाप. कुछ तो कर रहे हैं भाई. जिगजैग तो कर देंगे भाई, इसमें तो कुछ नहीं है. बट डिसेंडिंग ऑर्डर ऑफ साइज मेक सेंस. Okay, in a path of length k, this is k minus 1 in a cycle. So there are this. So which sort by size descending? Why? काम कर गया, लोगों ने पास करा दिया है, कुछ तो भी है, समझ गया मैं भी. कोई कुछ प्रूफ नहीं किया है. डीपी का सारा क्वेश्चन बनाने का सीक्रेट प्रॉब्लम, हाँ ये तो सीक्रेट है, बट ये सीक्रेट यूज कैसे करे क्वेश्चन में, वही तो नहीं होता है. पता ही है सबको कि उसको सब प्रॉब्लम में ब्रेक करना है. बट वो बनाए कैसे जिससे कोई भी प्रॉब्लम सॉल्व हो, वही तो नहीं होता है लोगों से. वही तो पढ़ाया है मैंने डीपी फ्रेमवर्क में, जो यूट्यूब पे भी अवेलेबल है, कि कुछ उसके स्टैंडर्ड तरीके ही है सब प्रॉब्लम में ब्रेक करने के. ओके. ठीक है निखिल, समझ गया. कूल. ठीक है, ये तो ग्रीडी प्रॉब्लम है, इसमें निखिल बोल भी रहा है कोई सोल्यूशन गलत है. सो विल नॉट स्पेंड टू मच टाइम ऑन दिस. बट आई होप कुछ कुछ क्लैरिटी मिली हो कि कैसे चल रहा है चीजें. ओके. But I was able to solve only two questions in today's contest and only one question in yesterday's. Okay. On campus intern season, what's the best way I can progress for lead code contests? Uh, और कॉन्टेस्ट दो, कवर मोर टेक्निक्स. आई थिंक जो टेक्निक्स हमने डिस्कस करा वो अगर नहीं पता है तो पढ़ो उनके बारे में. यशवंत आज ना हो पाएगा भाई, ये तो ना हो पाएगा. Someone tried using some logic. Okay. ये मैंने केस भेजा, उस ऐड नहीं किया लीड कोड ने अब तक. उस केस के सबके सॉल्यूशन फेल होते हैं. कैन डिस्कस यस्टरडेज ABCD प्रॉब्लम. नहीं यार, एड कोडर तो हम पिकअप नहीं करते हैं मोस्टली. बट आई थिंक प्रॉब्ली एड कोडर के डिस्कशंस माइट बी मोर इंटरेस्टिंग. मुझे अब लग रहा है लीड कोड थोड़ा बोरिंग होता जा रहा है दिन पे दिन. एड कोडर बिगिनर कॉन्टेस्ट के जो क्वेश्चंस होते हैं वो ज़्यादा बेहतर होते हैं. पता नहीं, मतलब माई पर्सनल ओपिनियन. I think you should definitely solve the DE problem of AdCoder beginner contests. They are really good problems to grow. Very similar to code lead code का uh, C या D वाला प्रॉब्लम. तुम लोग जो यहाँ पर बैठे हो, तुम लोग का मोस्ट ऑप्टिमल ग्रोथ विल कम फ्रॉम LC C comma D like third and fourth problems and AdCoder ABC का D comma E प्रॉब्लम. ये दोनों तुम लोग का जोन है जहाँ तुम लोग को मोस्ट ग्रोथ मिलेगा. CF पे ग्रोथ नहीं मिलेगा. CF इज नॉट अ गुड प्लेटफॉर्म टू प्रैक्टिस. वो बस कॉन्टेस्ट देने के लिए अच्छा प्लेटफॉर्म है. उसमें प्रैक्टिस करने का हो गया, मतलब एक टाइम था जब वो अच्छा था, उसमें अच्छे क्वेश्चंस है, बट रीसेंट क्वेश्चंस उतने तुम्हें लर्निंग नहीं देगी. मतलब देयर आर क्वेश्चंस व्हिच आर डिजाइन फॉर लर्निंग, देयर आर क्वेश्चंस व्हिच आर डिजाइन फॉर लाइक ट्रेनिंग लाइक टू. तो ये चार चीज में तुम्हें सबसे ज्यादा ग्रोथ मिलता है. यहाँ पर फोकस करो प्रैक्टिस करने का. तुमसे कॉन्टेस्ट में तो AB ही बनेगा और इधर भी ABC ही बनेगा, बट उसके बाद ये दो दो आप सॉल्व करते रहोगे, इवेंचुअली 2 मंथ में बनने लगेगा एक नेक्स्ट नेक्स्ट वाला तुमसे. Yeah, I do suggest AdCoder at most times. I think you might have seen Santan's podcast on my channel, and like you will, I'll encourage you all to watch his podcast. So he was one of former students, and he after the course he completed at he practiced only on AdCoder क्योंकि मैंने AdCoder बोला था. तो he had reached later on मतलब 1900 टाइप का on CF also level. आराम से, कैंडिडेट मास्टर एंड ऑल। यस, तो कर सकते हो प्रॉपर्ली ये अच्छे से। ओके, चलो आई थिंक हमने सारे तो मेन तो प्रॉब्लम डिस्कस कर ही लिए। इट्स गुड टू बी बैक एंड डिस्कस दीज थिंग्स। क्विक गाइड, 7 कॉस्ट टेस्ट में सेम। नहीं नहीं यार, वो एड कोडर पे प्रैक्टिस कर रहा था, वो भी एक चीज था। ठीक है, ही वाज प्रैक्टिसिंग ऑन एड कोडर अलॉट। डोंट गो बाय ग्राफ्स, इट समटाइम्स आर मिसलीडिंग। ठीक है, if it's not their main like practice platform, then you can see non-relevant graphs. I'll not say he got CM in the 7 contest. He also practiced a lot on at coder before he went on to CF. तो वो भी था पीछे। या आई मीन, तुम लोग मेरे यूट्यूब के चैनल के वीडियोस देख सकते हो यार बैठ के। देर आर सर्टेन वीडियोस विच आर वेरी हाई वैल्यू आई फील। उसमें मतलब कुछ कुछ सटल थिंग्स है जो तुम समझ जाओ तो मतलब है, कुछ तो वैल्यू है। अब मैं खुद से नहीं बोल सकता खुद के बारे में, बट आई थिंक उसमें कुछ कुछ चीजें हैं जो लोग जिसके बारे में नहीं पढ़ बताते हैं, एंड लाइक यू वुड मिस दोज थिंग्स। ठीक है, साइंथन 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 का वीडियो कहाँ गया? या साइंथन दो, CM इन 4 months था, बट आफ्टर ही केम टू कोड फोर्सेस उसके बाद इसने एड कोडर पे करा है वैसे। नेक्स्ट मतलब नेक्स्ट AZ premium is going to start from 31st of May. Okay, this, I think if you will see his graph, and this was before almost AI। मतलब ऐसा भी नहीं कि AI हुआ है तुम लोग सोचते हो ऐसा कुछ यूज किया, कुछ नहीं है। Okay, I'll send it on the chat. Okay, चलो कूल। आई थिंक दिस इज अ गुड प्लेस टू स्टॉप फॉर नाउ। ICPSC कैम्प के बारे में कल मैंने स्ट्रीम भी कर दिया था। इफ यू हैवंट जॉइंड इट, आई थिंक मोस्ट पीपल हियर शुड जॉइन इट प्रॉपर्ली। अगर तुम लोग ऐसे कंटेंट को एंजॉय करते हो तो ICPSC कैंप इज गोइंग टू बी वन सच कंटेंट प्लेस। ओके, एंड विल सी यू देयर। नेक्स्ट वीकेंड से तो ICPSC कैंप भी स्टार्ट हो रहा है, सो प्रॉब्ली सैटरडे को विल डू स्ट्रीम, संडे को एक्चुअली आई हैव अ क्लास एट 2 o'clock। उसके लिए अलार्म लगा रखा है कि बाई चांस कहीं सोता ना रह जाऊँ मैं, संडे भी रहता है ना। देन आई वोक अप अर्ली। Okay, chalo, I think this should be it. We'll wrap it up over here. Thanks for joining in, everyone. I'll see you all in the next stream. Yeah, I will do buying such application classes over. Chalo, I'll see you all in the next class. Bye bye. Have a good day ahead. Thanks for joining in the afternoon.